You're welcome back to my YouTube channel. I am Moses Oluwasegun Alex, and this is Programmed Mathematics. Now, in the previous video, I've explained how to find the cofactors of a matrix, the adjoint of a matrix, and I told you in that video that when you know how to find the determinant of a matrix, you can find the cofactor, the adjoint of a matrix as well. Then you can find the inverse of a matrix. So in this video, I'll be talking about the inverse of a 2 by 2 matrix. Okay, now why is the inverse of a matrix very important? Well, we need to solve a system of equation. In a layman's language, we're talking about solving simultaneous equation, okay, whether in 2 variables or in 3 variables or 4 variables. So we need to know the inverse of the matrix. All right, so first thing is the equation is converted to a matrix form. The matrix inverse is required in order to solve that problem. So if you cannot find the inverse of a matrix, then it will not be possible for you to use a matrix method to solve a problem of system of equations. So in this video, like I said, I'll be talking about the inverse of a given matrix. So in this, I'll be talking about the 2 by 2 matrix. Now, the inverse of a matrix, the inverse of a matrix, let's say matrix A, okay, let's say matrix A, say A, okay, is denoted by A inverse as this, and defined as follows, okay, as follows. Now the inverse of any given matrix, let's say matrix A, is equal to the adjoint of the matrix A, okay, divided by the determinant of matrix A. Okay, so adjoint in this case, in one of the videos I've explained that adjoint of a matrix is simply the transpose of the cofactor matrix, right? And of course, determinant here has also been explained in one of the videos. So you can help yourself with explanation on adjoint matrix and the determinant. All right, so this is the definition. This one also, if you so much desire, you can write this as 1 over the determinant multiplied by the adjoint of the matrix. Okay, so the adjoint of the matrix is the transpose of the cofactor matrix. Okay, so, and I told you also that the matrix of the cofactors, okay, is the matrix of the minors. Okay, of the matrix of the minors. So now, which means that if we need to find the inverse of any given matrix, okay, the basic steps here, if you have to find the inverse of any given matrix, step 1, you will need to first get the determinant of the matrix, obtain the determinant of the matrix. You need to get the determinant of the matrix. Once you have the determinant of the matrix, number 2, we need to get the adjoint. But before the adjoint, you must obtain the cofactor matrix. Obtain the cofactor matrix. When you have the cofactor matrix, then you can come here to find the adjoint. Obtain the adjoint. Obtain the adjoint matrix, okay, the adjoint matrix or adjoint of the matrix okay. Now this adjoint matrix can also be called the an adjugate matrix, okay. So whether you call it adjoint matrix or adjugate matrix, they both mean the same thing. So once we have the adjoint matrix, then the fourth step, step 4 is to divide the adjoint matrix, okay, by the determinant. All right, so this is what you have there. Now, when we say divide the adjoint matrix by the determinant, remember the determinant is going to be a scalar value. It's a scalar, so we can divide every element of the adjoint matrix by the determinant. All right, so in this video, like I said, I'll be taking 2 by 2 matrix. Now, let's say, for instance, matrix A, okay, matrix A is the matrix having the element A, B, C, D. So if we are to get the inverse of matrix A, okay, we can easily First, get the determinant of matrix A. The first step, the determinant of matrix A, that's A, B, C, D. Remember, the two vertical lines here tell you we are dealing with determinant. So in this case, we have the product of the elements on the principal diagonal minus the product of the element of the principal diagonal. So A times D, that's AD minus B times C. So this is BC. So that's for the determinant. Then the next thing is to get the cofactor matrix. The cofactor matrix. So let's get the cofactors first. Now, matrix A here is a 2 by 2 matrix, meaning we have 4 elements here. So the cofactor also is going to be a 2 by 2 matrix having 4 elements. So we need to find C11, C12, C21, and C22. That's for the cofactors. C11 is the cofactor corresponding to the first element on the first row, first column, which is A. C12 is a cofactor corresponding to the element on the first row, second column, which is B. C21 is the cofactor of the element corresponding to C. And then C22 is the cofactor corresponding to the element D. That's the second row, second column here. All right, so don't forget the sign convention. For the first element, we have plus. The second is minus. Here we have minus, and then this is plus. So for C11, the sign convention is positive. So we are going to have positive M11. Okay. Then C12, the sign convention is negative. So this is negative M12. We'll get the value from the matrix. And then C21, the sign convention is negative. So this is minus M21. And C22, the sign convention is positive. So this is M22. So now let's obtain the minor. M11 is the minor corresponding to elements on the first row, first column. First row, first column here, we delete the 2, we're left with D. The determinant of a scalar is still a scalar. So here we have D. So with D. Then C12, okay? First row, second column. We delete that also, we're left with C. Because of this minus, so this is minus C. Then C21, that's second row, first column. Second row, first column, we have B. So minus M21. M21 is B now. So minus M21 will mean minus B. And C22, that's second row, second column. Okay, we delete those two. We're left with A. So this is M22 is A. All right, so we have the cofactors there. Now let's get the cofactor matrix. The cofactor matrix, which is C. The cofactor matrix here is simply the matrix of the cofactors. So in this case, the cofactor matrix C is equal to C11, C12, C21, and C22. All right, so in this case, C11 is D. So we have D up here. C12 is minus C here. And then C21, second row, first column, that's minus B. Okay, minus B. And then, of course, the C22 is A. Okay, let's go back to this and check properly here. C11 is first row, first column, first row, first column D. C12, first row, second column, first row, okay, second column, that is C, okay, that's C here. All right, so we're still, so in this case here, minus B, minus C, then C22, that is A, so we have A here. All right, so this is the matrix of the cofactors. Once we have the matrix of the cofactors, the next thing is to find the adjoint matrix. The adjoint matrix of matrix A is the cofactor transpose. We transpose the cofactor. So if we transpose this, it means first row becomes first column, second row becomes second column. So first row, D minus C becomes first column, D minus C. Second row minus BA becomes minus BA. All right. So once we have this, we can then obtain the inverse of matrix A. The inverse of matrix A, like we said from the definition, is 1 over the determinant of matrix A times the adjoint of matrix A. So in this case, the determinant of matrix A is here, AD minus BC. So we have 1 over, okay, let me just 1 over AD minus BC multiplied by the adjoint matrix, which is this. This is D minus B minus C A. So this gives us the inverse of a 2 by 2 matrix. Now, mere looking at this, the inverse of a 2 by 2 matrix is very straightforward. Looking at this formula here. Okay, so without having to waste much of your time going through this long process, if the question asks you to find the inverse of any given 2 by 2 matrix, simply apply the formula here. Now, how do we do this? This is the matrix. First thing, find the determinant. Like we have here, multiply A by D minus B times C. That's the denominator. That's 1 over the determinant. Now, if you observe closely, what you have here and here, these elements on the principal diagonal, they switch their positions. Okay? A will take the position of D, D takes the position of A. That's what you have here. So switch these elements on the principal diagonal, switch them. Then the element of the principal diagonal, okay, multiply them by minus 1. Okay, so this times minus 1 minus C, B times minus 1 minus B. So A and D will switch position to give us the adjoint of the matrix. So in this case here, with this formula, we can easily find the inverse of a 2 by 2 matrix. Now let's pick an example. As an example, we want to obtain the inverse. Example, we want to find the inverse of A. If matrix A is the matrix of the element 2, 0, minus 3, 4. Okay, so we have this. So we want to find the inverse of the matrix A. Okay, now we are going to work out this step by step. Then we'll also follow the formula. So the solution to this, the first step says we should find the determinant of matrix A. So obtain the determinant of matrix A. 2, 0, minus 3, 4. If we obtain the determinant here, this is 2 times 4. 2 times 4 minus 0 times minus 3. 0 times minus 3. 2 times 4 is 8. Minus 0 times minus 3 is 0. So the determinant of matrix A is 8. Okay, so we have that as 8. Then the next thing, we obtain the cofactors. Let's get the cofactors. C11. C11, the sign convention is positive, plus, minus, minus, plus. So this is plus M11, the minor. Then C12, the sign convention is minus. This minus M11, the minor, M12. Okay, M12. Then C21, the sign convention is minus, so minus M21, and then C22, the sign convention is positive, M22. So let's get the M11 and M12 to M22. M11 means first row, first column deleted. First row, first column deleted, we are left with 4. Okay, this is 4 here. So this gives us 4. M12, first row, second column. First row, second column deleted, we have minus 3 left. But because of this minus here, minus times minus 3 will give us plus 3. Then C21, second row, first column. Second row, first column. Delete those two, you are left with 0. Okay, so 0 here. Because of this minus times 0 is still going to be a 0 here. Okay, then the last part of it is M22. Second row, second column, delete those two, we are left with 2. So we have 2 here. Okay, so we have the cofactors. Now, let's write out the matrix of the cofactors. Matrix of the cofactors. So the C in this case, we have C11 is 4, C12 is 3, C21 is 0, C22 is 2. So we have this as the matrix of the cofactors or the cofactor matrix. Then the next thing is the adjoint of matrix A. Adjoint of matrix A is the transpose of the cofactors. So 4, 3, 0, 2 transpose. So when we transpose this, 4, 3 row 1 becomes 4, 3 column 1. 0, 2 column row 2 becomes 0, 2 for column 2. All right, so we have the adjoint. Then we can find now the inverse of matrix A. So the inverse of matrix A inverse, is therefore equal to 1 over the determinant of matrix A times the adjoint of matrix A. And so in this case here, determinant of matrix A has been calculated here to be 8. So 1 over 8 bracket. Adjoint of matrix A is this 4, 0, 3, and 2. If you so desire, you can leave the inverse at this stage. And if you don't want to, you can multiply this out straight. This is a simple scalar multiplication. So 1 over 8 times 4, that's 4 over 8. 1 over 8 times 0 is 0. 1 over 8 times 3 is 3 over 8. 1 over 8 times 2, 2 over 8. So if you notice that the fractions can be reduced to their lowest terms, you can go ahead to do that. So 4 here is 1, 4 here is 2, 2 here is 1, 2 here is 4. So we check here now, this is 1 over 2, 1 over 2, this is 0, okay, 0 here, this is 3 over 8, and of course we are left with 1 over 4 here, so this is 1 over 4. Okay, so this is how we can find the inverse of a 2 by 2 matrix. Now, following the steps. First, the determinant. To the cofactors. From the cofactors, we got the cofactor matrix. Transpose the cofactor matrix to give us the adjoint. Then, the inverse is 1 over the determinant times the adjoint of the matrix. And I said here, if you want to, you can leave your inverse at this stage. And if you don't want to, you can multiply out, like we have done here. If you multiply out, I discovered that you have a fraction where the fractions can be reduced to their lowest term. Mathematically, the ideal thing is reduce the fractions to their lowest terms, like I've done here. Okay, so the inverse of this matrix A is this. Okay, now, what if you don't want to go through these steps? You just want to do the inverse straight without having to start calculating cofactors and the rest of it. Now, let's see that here, because this is also possible in the case of a multiple choice question, which some people refer to as an objective question. So direct method here, here now, the inverse of matrix A, we follow the formula straight, and that is 1 over AD minus BC. Switch the position. D comes here, A down here. This is minus C and minus B. Okay, so all we need now is find this one here. A, this is B, this is C, this is D. Okay, so 1, AD here means 2 times 4. BC is 0 times minus 3. So this is 2 times 4 minus 0 times minus 3. Bracket. Now, A in this case is 2. D is 4. So we are switching 2 and 4. 4 will come up here. 2 comes down here. As this. Then the element of the principal diagonal, we multiply that by minus 1. Minus 3 times minus 1 is 3. 0 times minus 1 is 0. And so if we simplify this, 2 times 4 is 8. 0 times minus 3 is 0. So this is 1 over 8. 4, 0, 3, and 2. Okay, so check this and this, they are the same thing. And so if you multiply out that, you are going to have 1 over 2, 0, 3 over 8, and 1 over 4. All right, so this is how the inverse of a given 2 by 2 matrix is obtained. Okay, so should you be given any question on this, you can decide to go by this method or go by the step-by-step approach as well. If you are going by step-by-step approach, remember the first thing is find the determinant of the matrix. The second step, obtain the cofactors. Then form the cofactors into the matrix to get the cofactor matrix. Once you have the cofactor matrix, obtain the adjoint of the matrix, which is the transpose of the cofactor. Once you have the adjoint, then we can divide the adjoint by the determinant. Okay, the elements in the adjoint matrix divided by the determinant. Okay, so and I also said that the adjoint matrix can also be called the adjugate matrix. They both mean the same thing. Okay, so this is how to find the inverse of a 2 by 2 matrix. So please, if this is your first time of coming in contact with this YouTube channel, this is programmed mathematics. Every bit of topic discussed here is from the foundation till the last part of it. So no topic is hidden as far as the secondary school level or college level is concerned. Okay, so please, I would love you to do me a favor by recommending the channel as well to everyone around you. Like the videos, give me thumbs up on the videos. Use the comment section as well to make your satisfaction or dissatisfaction known at the same time. Or should you have any question at all, please use the comment section as well to reach out to me, or check the video description. Okay, you see my other social media handle where you can as well reach out to me. Okay, so please, in the next video, I'll be explaining the inverse of a 3 by 3 matrix. The steps are not different. Okay, this is just 2 by 2. 2 by 2 has a straight formula that we can easily use, like I've given up here. We can make use of this, okay, to find the determinant of the inverse of a 2 by 2 matrix. But in the case of a 3 by 3 matrix, no, there's no formula for that. So we have to solve the problem step by step, from determinant to adjoint to the inverse. All right, so please, let's see in the next video.